Direct and inverse proportions, exercise 10.4, part 1. Here we look at compound proportion. What is a compound proportion? Sometimes change in one quantity depends on change in two or more quantities. Okay, in some or other proportion, change in one quantity depends on change in two or more quantities. So, in such cases, one quantity may be in direct proportion with two other quantities. One quantity may be in inverse proportion with two other quantities, or one quantity may be in direct proportion with one quantity and inverse proportion with another quantity. So, in such cases, these are all applications of compound ratios or compound proportions. So, first problem. Rice costing rupees 480 is needed for 8 members for 20 days. What is the cost of rice required for 12 members for 15 days? So, this is the question. Now, we'll write a table here. So, first we'll fill the details here. So, cost of rice, number of members and number of days. These are the three values we have here. So, in the first case, it is given 480 rupees rice is needed for 8 members for 20 days. So, then how much quantity or cost of rice is required for 12 members for 15 days? That is the question. So, we know that cost is directly proportional to number of members in the family. So, here if number of members in the family increases, the cost of rice required also increases and vice versa. So, here 480 is to x, that is, let us assume that x is the cost of rice required. So, this 480 is to x is equal to 8 is to 12, because this is a direct proportion. Cost is directly proportional to members. This is a direct proportion. So, we write the ratio as it is. 480 is to x equal to 8 is to 12. So, let this be 1. Now, cost is directly proportional to number of days. If we need rice for more number of days, the cost will be more. So, this is also a direct proportion. So, we write the ratios as they are. 480 is to x equal to 20 is to 15. So, let this be 2. So, both are direct proportions. Now, as the cost depends on both members and days, okay, we will take a compound ratio of these two variables. How? Cost is proportional to compound ratio of members and days. So, from equation 1 and equation 2, 480 is to x equal to compound ratio of 8 is to 12 and 20 is to 15. So, here let us simplify these two ratios. 480 is to x equal to compound ratio of 2 is to 3 and 4 is to 3. Now, what should we do? 480 is to x equal to, we should multiply the first two quantities here. So, 2 into 4 is to the next 2. 3 is 3 into 3. So, 480 is to x equal to 2 into 4 is 8. 3 into 3 is 9. Okay. So, what should we do now? Product of means equal to product of extremes. What are means? These two values. Okay. These two are extreme values. So, 8 into x equal to 480 into 9. So, x equal to 480 into 9 by 8. So, x equal to 540. So, cost of rice needed is rupees 540 rupees rice is required for the family. 10 men can lay a road of 75 kilometers long in 5 days. In how many men can 15 men lay a road of 45 kilometers long? Now, what are the three values here? Days, number of days, number of men and number of kilometers. Okay. So, here in 5 days, 10 men can lay a road of 75 kilometers long. So, how many days are required for 15 men and 45 km length of road? That is the question here. So, days are directly proportional or inversely proportional to number of men? Days are inversely proportional to number of men. Why? If we have more men, the work can be completed in less number of days. So, This is an inverse proportion. So what should we do here? 5 is to x is equal to inverse ratio of 10 is to 15. Inverse ratio means 5 is to x equal to 15 is to 10. Inverse ratio of 10 is to 15 is 15 is to 10. So let this be 1. Days are directly proportional to kilometers. Okay, if we have to put a road of more length, more number of days will be required. So 5 is to x equal to 75 is to 45. We write this ratio as it is because this is a direct proportion. This is a direct proportion, so it can be written as it is, this ratio. Okay, but here we have to write the inverse ratio because it is an inverse proportion. Now, as the number of days depends on both values, we take a compound ratio of this 1 and 2. From 1 and 2, 5 is to x equal to compound ratio of 15 is to 10 and 75 is to 45. So let us simplify these two ratios. 5 is to x equal to compound ratio of 3 is to 2 and 5 is to 3. Now again, product of extremes equal to product of means. So 5 into 6 equal to 15 into x. So x equal to 5 into 6 by 15, x equal to 2. Therefore, number of days required equal to 2. 24 men working at 8 hours per day can do a piece of work in 15 days. In how many days can 20 men working at 9 hours per day can complete the same work? Here again we have three quantities: days, men and hours. Okay, 15 days, 24 men and 8 hours is the first one. So we want to find the number of days required if 20 men work for 9 hours a day. Again, let us take two quantities each and compare them. Days is inversely proportional, number of days is inversely proportional to men, because if we have more men working, the work can be completed in less number of days. So this is an inverse proportion. So we write the inverse ratio of men. So 15 is to x equal to inverse ratio of 24 is to 20. So 15 is to x equal to 20 is to 24. This is equation 1. Now, number of days is inversely proportional to number of hours a day, because if men work for more number of hours a day, number of days required will be less. So this is also an inverse proportion here. So what should we do? We should write the inverse ratio of 8 is to 9 again. 15 is to x equal to 9 is to 8. This is equation 2. As the number of days depends on both values, we take a compound ratio. So from 1 and 2, 15 is to x equal to 5 is to 6 and 9 is to 8. These are the two ratios. We have to take the compound ratio. That means 5 into 9 and then 6 into 8. So 15 is to x equal to 5 into 9 is to 6 into 8. So 15 is to x equal to 45 is to 48. Now product of extremes equal to product of means. So 45 into x equal to 48 into 15, x equal to 16. So number of days required to complete the work is 16. Like, share and subscribe for more videos on direct and inverse proportions.